Hi, everyone. Thanks for stopping by. I know it's the last talk of the day, so everyone's tired, but I really appreciate that you made it to my talk today. I'll be talking about Flutter and Supabase, basically, and how you can bring the power of Postgres into your Flutter app using Supabase. I'm Tyler, and I'm a DevRel at Supabase. I mainly focus on the Flutter side of things at Supabase, and I also maintain their Flutter SDK. So yeah, let's dive in. Before we get started, what is Supabase? For those that are not so familiar with Supabase, this might explain what exactly it is. So right in the middle, it says Supabase is an open source Firebase alternative. I think that's a pretty good summary. I think everybody knows what Firebase is, but the basic idea is the same. So you have, you can take Supabase and any kind of front-end framework like Flutter, which is our favorite one, and you can build a fully scaled application just with that without having to bring in any back-end engineers in the picture. So let's look at some features that we offer at Supabase. The core feature of Supabase is the database. And for the database, we offer a Postgres database. We offer a fully managed Postgres database for every single Supabase project you create. And I believe this is the biggest difference between Firebase and Supabase is that people love Postgres database. It's been around for over 30 years. It's such a highly scaled database, and Supabase offers it with the ease of just clicking a few buttons. We also offer authentication. So if you want to manage your users within your application, you can just use Supabase Auth to sign them up using email and password or OAuth. We also provide other SSO or other advanced authentication mechanisms as well. And storage is another core feature that's often used within mobile applications. So if you want to have your users upload some images, videos, PDFs, etc., then you can use Supabase storage. And the Supabase storage is tied in with our authentication system so that you can control how people can upload files to your Supabase storage. Real-time is another core feature of Supabase, and it's oftentimes used within mobile app. So with our real-time feature, you can actually listen to database changes happening in your Postgres database, and we broadcast those changes over WebSocket so that you can synchronously update your UI to be in sync with your database. Edge functions. So until now, all these database authentication, storage, real-time are mainly focused on the client side. But some logic cannot live in the client side, such as when you want to interact with, let's say, payment system in the backend. You cannot include your API key in your Flutter application, right? So for integrations like that, you can use the edge functions. And for edge functions, we provide a globally deployed edge functions powered by Dino, which is the TypeScript runtime. And lastly, we recently launched our vector database offering. Vector database has gotten very popular these past few months, especially with the merge of these advanced AI technologies. And with our vector database, you can efficiently query and store vector embeddings into your database. And when we develop these new features, there's one principle that we keep in our mind, and it's to use existing open source software whenever possible. And only if there's no software out there that actually does the job, we develop our own. So going back to the previous slide, we had Postgres database. Postgres database is open source, and we also provide a auto-generated APIs on top of Postgres. We use a engine called PostgREST. So that's Postgres with REST API put together, PostgREST. That's also a open source project that was already built way before Supabase. Authentication, we forked a authentication server project called GoTo that was developed by Netlify. We forked it, we added our own features on top of it, but the original version was already there. Edge functions, it's a Dino, so again, open source. It was already available. We're just using it. Storage, some of those transformation features that we offer within Supabase is open source. And vector database is powered by PG Vector, again, open source extension of Postgres. And real-time feature out of these 6 features is actually the only feature that we ourselves developed at Supabase. And it's actually one of the first product that our co-founders worked on. And we made it ourselves, and of course, we made it open source. So all the source code are out there for you to check out and contribute if you want to. And this open source nature of Supabase caught the eye of the open source community. And we usually compare the number of GitHub stars with React. But since this is a Flutter track, I thought it would be fun to compare the GitHub stars with Flutter. And as you can see, Supabase is about 3.5 years old. Flutter obviously is over 8 years old. Wow, okay. But you can see that Supabase is quickly gaining popularity, and it's on track to have more stars than when Flutter was at 3.5 years old. The best thing about Supabase is it's just Postgres. So we, again, provide a fully fledged Postgres database for every single Supabase project that we provide. And that means that every single feature that's offered in Postgres is available in Supabase as well. So you can set advanced constraints, foreign key relationship, database trigger to react to a certain database changes happening in databases, database functions, which is very useful when you want to interact with advanced data types, or transactions, extensions, etc. There's way too many cool Postgres features to name here, but I will go into some of them in more detail later on. And in order to interact with the Supabase database from your Flutter app, we developed a Flutter SDK for Supabase. You can find it in pub.dev. It's called Supabase Flutter. And I'll be going over some of these client library features now. So the first step to start using Supabase is to initialize your Supabase instance. You can go to supabase.com, create a Supabase project, and in that Supabase project, there will be a Supabase URL and Supabase anon key or anonymous key. These credentials are meant to be public, so they are okay to be stored in your client application. And you just pass those credentials to supabase.initialize. You typically initialize it within your main function of your Flutter app, and that's all that takes to get started with connecting your Supabase instance to your Flutter application. Once you connect your Supabase instance to your Flutter application, you can start by authentication. So Supabase offers variety of authentication methods. We have the magic link sign-in, sometimes called passwordless sign-in, which it works by Supabase sending an email containing a sign-in link to the user. Users can just click that link to complete the sign-in. We also provide typical email and password sign-up, OAuth sign-in, two-factor authentication, single sign-on. All the advanced methods are available, so you can get started with whatever authentication needs you might have for your application. Authorization is the another key component of auth, right? So authentication signs user in. Authorization verifies that any incoming access has actually the authorized access to access whatever data they're trying to access. And Supabase does authorization using a Postgres feature called role level security. What this row-level security allows us to do is it allows us to set a policy that if the policy evaluates to true, they have access to certain data. And if it evaluates to false, they don't have access to certain data. A simple example of this would be, if you're developing like a to-do list application, you might have a insert policy, and that insert policy might look something like auth.uid equals user ID. This expression means that the auth.uid is the authentication user ID that is generated by Supabase auth, matches the user ID column that they're trying to insert. So this makes sure that the user is not trying to impersonate someone else. Now on to some CRUD methods or REST APIs that Supabase offers. All the Supabase client SDK tries to mimic the syntax of a SQL statement. So on the top, you see a standard SQL, select all from messages. So we're selecting all the columns from messages table where user ID matches a certain value, and we're just ordering it by created at. Below, you see what that particular query looks like using the Supabase client library. So we always start with the Supabase instance, so Supabase dot, and then we can chain from method. This is specifying which table we're trying to interact with. And then we're calling the select method, so we're selecting data from the messages table. And then we chain an EQ filter. So EQ stands for equal, and we're trying to find where the user ID column equals a certain user ID. And last, we order those data by query created at column. So you can see the resemblance between SQL statement and Supabase client library implementation. Moving on to slightly more advanced queries. So you can also join table using Supabase client library. And it'll look something like this. So again, we're starting with Supabase dot from, and we're creating a post table. Let's think of it as if we're developing a Twitter clone application. On Twitter's timeline, we have lists of posts. And not just those posts, but in the individual posts, we have the user's profile picture, user's username, and we also have things like likes and how many likes this particular post has received. We can actually fetch all those data in a single Supabase query. So Supabase.from posts, and we're getting the post table. And the first star within the select statement means that we're getting all the columns of the post table. The following line, profiles, means that we're fetching the related profiles information for each of the posts within the post table. And similarly, the following likes means that we're querying the likes data and how many likes each post receiving for each post. And last, we're just ordering it by created at, and we are getting the 20 most recent data. Keyword search is another common feature that comes up in app development. And Supabase actually has a built-in feature. Well, Postgres has a built-in keyword search feature, and Supabase is just exposing that in an easily handled manner. And the client library has a convenient method called text search. And all we need to do is we need to provide which column we want to perform the search on and provide the keyword. In this case, I'm trying to search for JoyCon contents. And as you can see, you can easily implement a free word search feature. And listening to real-time data is also easy using the client library, and it's well integrated into the Dart ecosystem. So here we are starting with the Supabase dot from, pretty standard. And then instead of calling dot select, we are calling dot stream this time. And what this dot stream method does is it broadcasts the real-time data to the client. So it automatically sets up the WebSocket with the server, and it starts listening to real-time changes on the client side. And this is just a regular stream that we're used to using in Dart. So it'll once you listen to it, it'll return a stream subscription. I've omitted it in here, but you should always get the stream subscription and then dispose it when you don't need it. Supabase storage, again, very simple API. So I have some example of uploading and getting the image URL here. We start by supabase.storage. So we're accessing the storage feature of Supabase. And then .from post means that we're accessing the posts bucket of Supabase storage. And then we can call the upload method to specify which path we want to upload it to and the file that we want to upload to the storage bucket. Getting the URL of the image is similar. We start by supabase.storage.from, specify the bucket, and then we can just call the get public URL method to get the URL of the image. Now, I want to talk about edge functions. And earlier when I talked about edge functions, I mentioned that we offer edge functions powered by Deno. And Deno is a TypeScript runtime. But luckily, Invertase, our partner, have developed a tool called Dart Edge, which converts your Dart code, Dart server-side code, into valid JavaScript code that runs on our Edge runtime. So the code example you see here is an actual Dart Edge code written in Dart, and after compiling, it actually runs on our Edge functions. So you can truly develop a full stack application powered by Dart. Now I'd like to go into slightly more advanced Postgres features. Postgres functions is a powerful feature that allows you to set some abstraction on top of complex Postgres logic. So in this example, I'm creating a hello world function. It's a simple function that returns a hello world text upon calling. And on the client side, on the right, you can call it by calling the supabase.rpc method. Now, Postgres functions can be used when you want to run transactions or when you want to interact with advanced data types. And I'll talk more about advanced data types later. Another example, cool feature that might come in handy is database webhooks. So this is a cool feature that you can use when you want to, let's say, send a push notification. What database webhook allows us to do is it allows us to listen to certain database changes happening in your Postgres database, and it'll send a webhook request to a specified endpoint. Coming back to the Twitter example, when someone likes a post, you want to send a push notification to the person who posted the original post saying, hey, this person liked your post, right? In this kind of scenario, you can set a database webhook that listens to insert events on your likes table. And what this does is every single time someone inserts a data into the likes table, it'll fire a webhook to your specified endpoint. And from your endpoint, you can send a push notification to your end users. Now, Postgres extension is the advanced data type that I mentioned earlier. And these are very powerful features that you can use within Postgres. What this does is Postgres by default has a lot of features and has a lot of data types. It even supports JSON types, so you can have a column of type JSON. But anything beyond that, it doesn't support natively. However, Postgres has this ecosystem called extensions, where third-party developers can develop their own original data types or original functionality on top of Postgres to provide advanced features. And I will talk about two examples here. One example is PostGIS extension. So what this allows us to do is it it comes in handy when we are building anything with maps, basically. So let's say we are building a restaurant search app, kind of like Yelp maybe. In this scenario, we might create a table named restaurants, and this table will have ID column, name column, and a location column. This location column has type of geography point. That means it's a single point within a map. It holds the latitude and longitude within this map space. What this geography point allows us to do is it allows us to easily create commonly used case like closest neighbor search query or bounding box search. So closest neighbor search is a use case where you want to find, given a single latitude and longitude point, you want to find, let's say, the 10 closest restaurant from that point. This is a commonly used case when it comes to map-based applications, and it might be hard to efficiently implement something like this without the help from Postgres extension. Bounding box search is another common use case, and it's the one shown in the picture on the right, where you have a certain bounding box, and you want to find every single restaurant that are located within that bounding box. So this would be very useful when you have a map view, literally, and you want to display all the restaurants that are located within your map that's shown at any given time. Another one of my favorite extension is PG Vector, and this is what powers the vector databases that Supabase offers. It's becoming very popular lately with the emerge of AI databases. And for those that are not so familiar with vector database, what it does is it converts data into a vector. And oftentimes, those vectors are called embeddings. And what these vectors does is it contains some kind of semantic information about the data given in the first place. For example, let's say we had 3 sentences. The cat chases the rat, a cat is chasing its prey, and I want to eat a tasty ham sandwich. Let's say we converted these sentences into vectors. It'll come out something like this, where the first 2 sentences have semantically similar meaning. So in this case, those vectors will point at somewhat close location within the vector space. And the third sentence, I want to eat a tasty ham sandwich, this has nothing to do with the first 2 sentences. So it's going to point somewhere else, very far away. And without going into each of the sentences, by just by looking at these vector space, we can tell that the first 2 sentences have somewhat a similar meaning, whereas the third one is saying something totally different. Now, how is this useful? It's useful for many things, but one example that I have is a similarity search. So let's say we are building like a Netflix type of application. And in this application, after a user watches the movie, we want to recommend the next movie for the user to watch. And to recommend a good movie that users might be interested in, we want to find whatever is similar to the previously watched movie, and we want to recommend those movies as the next movie to watch. So in the screenshot on the right, you can see that the user watched a Blue Beetle movie, and below there's a You Might Also Like section that are automatically recommended using the Supabase vector search features. To implement this, we can create a movies table that has ID, title, overview, and most importantly, embeddings column. This embeddings column contains a vector, and we can use technologies like OpenAI or Hugging Face to generate these vectors from all the information that we have about movies. And then once we have all those vectors representations in our Supabase database, we can easily query what other movies that are similar to a certain given movie. I'm not going to go into the implementation of this, but if you're interested in hearing more, come talk to me after this talk. And now from here on, I want to do some live coding of actually implementing a simple application using Supabase in Flutter. So let's see how it goes. So I'm at the Supabase website. This is always a good place to start. In this Supabase website, we can get started by clicking this dashboard. If you're already signed in, if you're not, you can just sign up using your GitHub account. It literally takes less than 30 seconds. Now let's create a new project. And we can call this to-do list. So we're creating a to-do list application today. We can set a randomly created secure database password. And we can select the region to be in London. Let's hit create new project. And while that project is spinning up, I have a sample barebone application created right here. So let's go over what is going on in this application. I have installed Supabase SDK already in here. So it's in my pubspec .yaml file, but I haven't implemented any Supabase related features yet. So we're going to implement those together. So as you can see, it's a simple to-do list application. If I scroll a bit, it has a list view, and it just has hard-coded 10 list items. And each list item is also hard-coded. It says it has a text of list item. And the checkbox is always false. So we'll be dynamically updating these values using Supabase real-time feature. If you scroll a bit down, we have a dialog. So upon clicking the fab, we can add a new item. We can create a new item, hit add button, and right now I haven't implemented anything, but we'll be implementing it together. So that piece of code is here. We have a text field to enter a new to-do list item, and then we have a button that'll populate, insert new data into our Supabase database. So right about now, Supabase project should be done setting up, and we can find the Supabase credential right here at the bottom of our homepage. So let's start out by initializing Supabase. We can make this main function async and call await Supabase initialize. Now in this initialization code, we need to provide Supabase URL and Supabase admin key. We can obtain them from our Supabase dashboard. So just copy and paste Supabase URL and Supabase admin key. And that is all that takes to connect your Supabase instance to your Flutter application. There's no dragging and drop configuration files or anything. You just literally need to copy and paste to credentials, and that is it. Now, once Supabase is initialized, I always like to have a Supabase variable so that I can easily interact with the Supabase service. So Supabase instance.client, and this is going to be the entry point for all of our Supabase operations. So let's start out by creating inserting a new data. Scroll all the way down to where we see the button, and we can insert new data into our Supabase database. We can make this function async, and then call await Supabase from, and we need to give the table name here. Since we just created our Supabase database, we don't have a table yet, so let's create it together. We can click the table editor. There's two ways to create tables. There's two ways to generally interact with Supabase in general. There's the GUI and there's the SQL editor. So since everything Supabase provides is centered around Postgres database, you can always tweak these configurations using SQL, standard SQL. So you can create tables, you can edit tables using SQL, But for those that are not so familiar with SQL or Postgres in general, we also provide a GUI. So we can go to the table editor to create a table from our GUI. We can hit the new table button, and then we can give it a to-dos for the table name. Now, this checkbox enables row-level security, which is the security mechanism that Supabase offers. But we just want to get up and running quick for right now, so we are going to disable it, meaning that technically anybody with the Supabase credential can write and read any kind of data into our database. In production, we will always need to enable it, but we are going to disable it from right now. And enable real-time, we want to check this one because we want the to-do list to be real-time sync in with our client applications. And for all the columns, we can, by default, we have an ID and created at column. We can also add a title column, and this is going to be of type text. And we're going to say this title column can never be null. We can also add a status column. So status, and this is going to be type Boolean, and this can also never be null. And we are going to give status a default value of false. We can hit save. And that's all it takes to create a Supabase database. We have a to-dos table. So let's go back and edit our client side logic. So we can call .from.todos. And then we're going to insert some data into it. And this insert statement just takes a standard map. So we can insert a title, and we can get the title from item controller. So item controller dot text. So this controller is the controller that's connected to the text form field. And just like that, since all the other columns such as status, ID, created at has a default value, we don't need to specify them on the client side. They will automatically be given a value on the database level. So this is all we need to do in order to insert some data into Supabase. And let's try it out. We can add item. Let's see, new item. Hit add. We didn't get errors, so that's good. And if we go back, without refreshing the page, the newly inserted item shows up in our database. It looks good. The title is new item, status false. Everything looks perfect. Now let's try to display this information in our list view. So we can wrap this list view builder in a stream builder. And then the type of this stream is always going to be a list of map of type string in dynamic. And we can construct a stream here. So it's going to be supabase.from. And again, we're listening to the to-dos table. And we can probably order it by, and then call the stream method. And then the stream method takes a primary key of the table, which is ID. And then we can probably order it by created at timestamp. So just like that, we constructed a stream builder. We can get the value. So let's handle the case where we haven't got the data yet. So snapshot dot has data is not true, then we can return a standard preloader. And past that, we know that we have rows returned from Supabase, so we can put them into our rows variable, and this is going to equal the snapshot.data, and we know that the data is always there, so I'm just gonna add a exclamation mark, and we can dynamically change the item count. This is always going to be the rows.length, and we can also extract the row single row is going to be rows of index. Oops. Awesome. Now we can update the status. So we can access the status by rows status. And we can also update the text here. Title text is going to be row of title. Row of title, and this is not going to be a constant. Looks great. Okay, and just by refreshing the page, we got a nicely working to-do list. We can add more item, another item, and we can see that without refreshing anything, the item just gets inserted. Let's also update this unchanged logic so that we can actually update the status of each field. So in here, we want to update the data. We can take await Supabase. We need to make this async. Dot from to-dos, and we want to update the data. Now here we want to update the status column, and we want the status column to be the new value. Now here we can chain a filter. In this case, we can chain a EQ filter. Make sure that not every row will be updated. We want to target only those that we are trying to update. So we can filter targeting by ID value, and we are targeting the ID value that we obtained from our row. So hopefully this works, fingers crossed. Okay, just like that, we can update the status in real time, and you can see that everything works in real time. We can add more data. But yeah, just like that, you can easily construct a fully working real-time application using Supabase. Yeah, so hopefully you saw the simplicity of how easy it is to get started with Supabase and Flutter. And if you're interested in doing more with Supabase, if you want to create your own Supabase instance, database.new is a great place to get started with it. It's actually a domain that we own, and database.new redirects you to a page where you can create a new Supabase instance. So just remember this domain, and you can always come and create your first Supabase database if you haven't created one yet. Thank you so much. And build in a weekend, scale to million. This is our tagline. Postgres scales very good. So Supabase is a great starting point for starting real small, but it also supports enterprise grade scale application as well.